7.3, we're starting using row transformations, which is similar to solving the 3x3 equations in the math that you've done, except now they've taken away the variables and they've put them in matrix. So they want us to start off very small, and for number 3, they want us to do row operations, and they've written down this wonderful notation. And they're doing this because you have to understand the notation for what's going to come further. So this means we're going to multiply row 1 by the number 2. So we're going to take row 1 and multiply it by the number 2. That will give us 2, 10, and 12. And the main thing to remember is nothing actually happens with the first thing mentioned. So row 1, although we do this math, we don't actually change the values in that row. We do, however, change the values in the second mentioned row. So this will change, row 2. All right, so if we do this, row 1 does not change, but we do have 2 times row 1 in red. So now we're going to add the values in red to row 2. So 2 and negative 2 is 0. 10, 3 is 13. 12 and 1 is 13. And there was no mention at all of row 3, so row 3 is just hanging out. And that is the matrix that they're looking for with those row transformations. So you're done. For number 9, they want us to take the system and write it as an augmented matrix, which essentially means take away the equal signs, take away the variables, and put them in a little box. Okay, so x has a variable or a coefficient of 1, y has a coefficient of positive 5, and we've got 6. Keeping in mind, I'm going to write these really light. So this will be our x, this will be our y, this will be our constant, and in between is our little equal sign. All right, our second row, we don't have a y, so y will have a coefficient of 0. X is 1, and our constant is 3. And that is what the augmented matrix looks like. We're going to do the same thing for number 11, except now we've got 3 variables. So our first row across will be 2, 1, 1, and our constant is 3. Second row, 3, negative 4, 2, negative 7, 1, 1, 1, 2. And we're not doing anything with it right now. They just want it to be done in the augmented matrix form. So we've done it. With 15, they want us to go backwards. They're giving us the augmented matrix, and they want us to write the system of equations. Usually, the columns stand for X, Y, Z. If you want to use, A and B, it does not really matter. So our written out equations would be 2x plus 1y. If you'd like to put your 1, you're more than welcome. If you don't want to, you can just put y. Our second equation, 3x minus 2y equals negative 9. Again, they don't ask us to do anything with it. They just want to know, can you go back and forth between the augmented matrix and the system? 25 says each augmented matrix is in row echelon form and represents a linear system. Okay, so row echelon form means that you can get an answer from your matrix. And what I mean by that, if you look at this third row right here, we don't have any x's, we don't have any y's. We know that z is equal to 1. So we've gotten an answer out of this matrix. That means it's in row echelon form. We don't have the answers to every single variable. We don't know right away that x equals duh and y equals duh. That's called reduced row echelon form and requires a little bit more work. But row echelon form means, hey, I got an answer and I can actually go find the rest of the variables. So let's do that. Now my second equation, my third equation gave us one answer. If I write down my second row, what it represents, it says y minus z equals 2. Since we know from the last equation that z equals 1, we can say, okay, y minus 1 equals 2, so y equals 3. All right, so we're figuring out our variables. Now the very the very first row, the last row that we're going to deal with, represents x plus y minus z equals 4. So with our information, we can say x plus 3 minus 1 equals 4, x plus 2 equals 4, x equals 2. So we have 2, 3, and 1 is our solution for 25. 27, very similar to 25. Each augmented matrix is in row echelon form. Remember, row echelon form means we can get an answer out of this. We may not be able to get all of the variables out, but we can get an answer. Now, usually what you do is you look at the last row. Well, when we look at this last row, I have 0 equals 0. That means infinite solutions. Now, you are going on to calculus, and so your calculus instructor probably isn't just want to know what is infinite solutions. So what we're going to do is we're going to write the second equation, or second row, as an equation. So, not x, no x. We've got y minus 2z equals 1. And what I'm going to do is I'm going to solve for y. So y equals 2z plus 1. And what we're going to do is we're going to write parametric equations. And parametric equations are what you get when you have infinite solutions. So what I'm going to say is z can be any number, And the reason I'm saying that is because it says we have infinite solutions. So z could be 1, z could be 5, z could be -8, z could be anything we want. Now, every other variable, x and y, is going to be based on what we pick for z. So our y value is equal to 2z plus 1. So we have y, it's in terms of z. Since we said z is going to be our independent variable, or dependent, everything's going to depend on z. I have to now go and move my top row, x plus 2y minus z equal 5. I don't have a lot of room, so I'm going to bring that down here. So x plus 2y minus z equals 5. I'm going to isolate x, so I will have negative 2y plus z equals 5. And you can write these in any order. You could write 5 minus 2y plus z. It does not matter. But the problem is my x has a y value and a z value. That does not work. You can only solve when you have one other variable. So we want this in terms of z. I'm going to take the value for y and substitute it in for y. So I have x equals negative 2 parentheses 2z plus 1. Then I still have the plus z. And I still have the, that should be a plus 5. I apologize. Plus 5. So when I do a little math, I have negative 4z minus 2 plus z equal, I keep putting equals, plus 5, which combines to negative 3z plus 3. So if I were to actually write the ordered triple, which means the x, y, and z answers, my x value would be negative 3z plus 3. My y value would be 2z plus 1. And then everything depends on what we write for the value or choose for the value of z. And that's how you get infinite solution. Every single person in the whole wide world could pick a different number, and their x and y values would depend on that information. Infinite solutions. So this is how you write infinite solutions as parametric equations. And that is 27. Now 29 looks very similar to 27. However, if you look at the last row, we have 0 equals 4. Well, that means no solution. And there's nothing special you can do with something that is no solution. There's no parametric equations. There's no x equals this, y equals this. All you can say is there are not any numbers that you could substitute in for x, y, and z that would make this sucker true. So we're done. No solution. Now we're going to get into the nitty-gritty of this section. So 31 and 33 are the very beginnings of solving a system a different way. Now, absolutely, if we look at 31, we could add those two things together right now, get 2x equals 4, and we know already that x equals 2. But we're going to take the long way round because some of you are computer majors and you need to know how to work with matrices and what they look like. So, I said this many times in class. Yep, there are ways you can solve this, and it's much easier when you're using the letters. There are sometimes the matrices are quicker. This is going to be a little bit longer way. So the directions say use row operations on an augmented matrix to solve each system. Round to the nearest thousandth when appropriate. So they want us to round to 3 decimal places if necessary. All right, so looking at 31, we're going to set up our matrix first. And it would be 1, 1, 5, 1, negative 1, negative 1. So remember, we want our matrix to look like this. We want 1s on the diagonal, and we want 0s underneath those diagonal ones. What does that mean? That means I need to have a 0 in this space right now. So what I'm going to do, since I need to get rid of a positive 1, I'm working in column 1. Okay, I'm working in column 1. That means I'm going to multiply row 1 by the opposite of what I'm trying to get rid of. So I'm going to multiply row 1 by negative 1. And then I'm going to add that to row 2. Okay, now remember, when you multiply your row 1, you're not actually changing those values. We just write them somewhere else. So I'm going to put negative 1, negative 1, negative 5. Row 1 does not actually change. Only row 2 changes. So I'm still going to have 1, 1, and 5. But what I am going to change is the second thing mentioned is row 2. So I'm going to take these values, I'm going to add them to row 2, and that becomes my new row 2. Negative 1 is negative 2, negative 5, and negative 1 is negative 6. So that's my first step in row operations. Yippee. So what's the good news here? Well, the good news is I have a 0 in the bottom left. My next step, because row 1 is pretty much taken care of. If you look at what we want a 1 and then any numbers in our first row. In our second row, we want 0, which we've got, but we want our second column to have a 1. The only way, not necessarily the only way, but to get a 1, mainly you're going to divide by what you want to get rid of. So what I'm going to say is we're going to take row 2 and divide by negative 2. I want to get rid of negative 2 to become a 1. So what happened to row 1? Nothing happened to row 1, so it's still 1, 1, 5. If I take row 2 and divide it by negative 2, every single entry, 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is positive 1. Negative 6 divided by 2 is positive 3. I have what I want. What do I want? I want answers. So I have my x, I have my y, I have my constants. Well, I know that y is 3. So I have an answer. And then using my first row, x plus y equals 5, I can substitute that 3 and find out that x is 2. So my solution is 2, 3 for 31. And yes, at the beginning, like I showed you, we could have done that in 2 seconds with the variables. However, we get to play with this section and take the time and do each problem with a matrix. Oh yeah. All right, so let's set this one up. 33, very similar. So we're going to have 1, 1, negative 3, 2, negative 5, negative 6. Now it's a little bit different, not extremely different from the other problem that we just did. We still have 2 variables and a constant. So we're going to have 1 in the top left with numbers. Then we're going to have 0, 1 in the second row with a number at the end. Our job is to get it to look like that. All right, now to get a 0, remember you do the opposite. You multiply by the opposite in whatever column you are working in. So the 2 is what I want to change. It's in column 1. So I'm going to multiply row 1 by the opposite. I'm going to multiply that by negative 2. And remember, I'm allowed to do that because I have the 1 already in the top left corner. So I'm going to multiply row 1 by negative 2. So when I write out my notation, it looks like that. And then I'm going to add those answers to row 2. Let me say add to row 2. Okay, so when I multiply row 1 by negative 2, I'll have negative 2, positive 6. Do you need to write positive 6? Not really. Okay, now even though we multiplied negative 2 row 1, that occurred first, we do not change the first row. Row 2, however, we're going to take these values, add them to row 2, and our answer is what we write down. Negative 2 and 2 is 0. Negative 2 to negative 5 is negative 7. And positive 6 and negative 6, positive 6, negative 6 is 0. Now, although we do know some of us know the answer, most of us know the answer, I'm hoping all of us know the answer, we still want to have it in that row echelon form, which means a 1 in this space. So the last thing we're going to do is we're going to take row 2 and divide it by negative 7. So row 1 remains the same. If we divide negative 7 by negative 7, I get positive 1. 0 divided by negative 7 is 0. So now we know that y, let me write that a different way. Hold on one second. I know from this equation, or this row, that y equals 0. From this row, I know x plus y equals 3. So x plus 0 equals 3. So x equals 3. So the solution to this system is 3, 0. And you can always check your work if you really want to. Just saying. If we put it in the top, 3 plus 1, or 3 plus the... Whoa, I screwed up. Something happened. Oh, I lost a sign a long time ago. Oh, you guys. Okay, I'm going to put that in because it's not going to affect our world in any way, shape, or form. Negative 3, negative 3, negative 3, negative 3. See, that's what happens when you check your work. You screwed it up. Okay, so all of my 3 should have been negative, and since when I multiplied, oh dear, did I screw it up? Let me see, negative 2, row 1. Oh no, I did that with the negative 3, so I'm okay. Ah, dear heavens to Betsy. Okay, so watching your signs, now let's check it. So if I put negative 3 plus 0, that's negative 3, good. If I put negative 3 and 0 in the second equation, 2 times negative 3 is negative 6, minus 0 is negative 6. Okay, so I found my negative when I did my check. Oh, look at that. You should do your check. Now 35 challenges the steps that I gave you. And it makes you, well, hopefully it makes you think and go, wait a minute, I don't really have to do exactly what she told me to do. So what I mean by that, let's write the matrix first, the augmented matrix. So we have 2, -3, 10, 2, 2, and 5. So remember, our goal, we want a 1 and any numbers in our first row, then we want a 0 and 1 and any number after that. That's our goal to get our matrix in that order. Usually, you want to start off where you have the 1 in this upper left corner. It makes the math much easier to complete when you have a 1 in this upper corner. Now, when I'm looking at this, I also notice I need a 0 down here, and it would be so much easier to deal with that 0 first. So that's what I'm going to do. Now, you guys, you can do this in any order you want to. This is just something that I am seeing. Oh, no, undo what I just did. Okay, if you only want to do the steps exactly as I said them, do it that way. Nobody cares. I'm just seeing it'll be a lot easier right now if I just take row 1, multiply it by -2. Okay, row 1, multiply it by -1, and then add it to row 2. I just see that 0, and it makes me very happy. So I'm going to multiply the top by -1. So I'll have -2, +3, -10. Now remember, whatever you write down first, that doesn't change. The second row, however, 0, and that's what I wanted. 5, -5. Oh, that just makes me so happy. Okay, and even if you wanted to, you could go get the 1 right now too, because it's so lovely. So I'm going to do that. So I don't usually do that because if whatever you do in row 1 could affect your other. Actually, I'm not going to do that. Okay, so let's take care of row 1. I need a 1 in this top left corner. I need a 1 right here. So to get a 1, usually we're going to take row 1 and we're going to divide by whatever number I want to make a 1. So 2 divided by 2 is 1. -3 divided by 2 is -3 divided by 2. 10 divided by 2 is +5. And then I have 0, 5, -5. Now, -3/2 is a very nice decimal. So if you want to change that to -1.5, feel free. If it is a hideous decimal, please do not do that. All right, last but not least, we're close. I have my 1 and then any number, and I have my 0, but I need a 1 here to be in row echelon form. So like I just said, to make it a 1, we're going to divide by that value. So we're going to take row 2, divide by 5. So my first row doesn't change. That's a 3, believe it or not. 5. And then 5 divided by 5. 0 divided by 5, of course, is 0. 5 divided by 5 is 1. And -5 divided by +5 is -1. We now have row echelon form. What the heck is row echelon form? Row echelon form means I have an answer. And it's not Z. It's Y. Y equals -1. X, Y, constant. So I know Y equals -1. Now my first row tells me Y, not plus, but X minus 3/2, Y equals 5. So if I put in X minus 3/2 times -1 equals 5, I'll have X plus 3/2 equals 5. So X equals 5 minus 3/2. Now, some of you said 5 minus 1.5, which gives you 3.5. That's fine. And we knew y is -1. Now, it says round to the nearest thousandth, so they want us to do decimals. Okay, so we're done. Now, if you're a fraction person, you could do this. Find your common denominator. Get 7/2. It's the same thing. So if you're a fraction person, I'm good with you having a fraction, but since the direction said round when necessary, we'll go with 3.5 -1 for number 35. I don't know why they wanted us to do that. Maybe they say thousandths when that's a hideous decimal. I like the fraction, whatever one you like, since it's a nice decimal. We're good. The first thing you want to do when these is definitely go over, did you write the problem down correctly? So we should have x plus y minus z is 6. Yep. 2x minus y plus z is -9. And x minus 2y plus 3z is 1. This is where you really need to be good at this. This is the more of the problems that you're going to have. So when you have a 3x4, we want our matrix in the end to look like 1 with any numbers in the first row, a 0, 1, any numbers, and then a 0, 0, 1 with just a number at the end. If I could make this bigger. So this is x, y, z, and your constant. So what this does is in the end, it tells me z is this number, and then we can go do back substitution. That's what we like. Now, my recommendation is to always work down the first column, meaning get this first column, and then go over and work on the second column, and then go over and work on the third column. That's what I recommend. So let's write this matrix. So 1, 1, -1, +6. Let's try that again. And then 2, -1, 1, -9, 1, -2, 3, 1. Okay, so we have good news. The good news is we are starting out with a 1 in this top left corner. If not, you can always switch rows to get a 1 there, or you would have to divide everything in that column to get a 1. You could also add, there's a whole bunch of things you can do. I gave you specific choices, do this, do this. If you guys have that number sense and you're like, I can get a number I want doing it this way, do it that way, okay? The reason I give my steps is it's just a way to follow that works each time if you're doing your math correctly. All right, so I'm going to work down, which means I want a 0 underneath this 1 that I've circled. In order to get a 0, you multiply whatever column this is by the opposite of what you're trying to get rid of. So I'm going to try to get rid of this 2. I'm in column 1, so I'm going to multiply row 1 by the opposite of what I'm trying to get rid of, which is 2. So I'm going to multiply by -2. Then I'm going to add that to row 2. Now notice, I am not doing anything with row 1. I am doing -2, but remember, that doesn't change. So I'm still going to have 1, 1, -1, 6 in row 1. And in row 3, it's not being touched either. The only thing you change is whatever is mentioned second. All right, so let's do this math. I'm going to multiply row 1 times -2. So -2, -2, +2, -12. I'm going to add those numbers to row 2. So -2 and 2 is 0. -2 and -1 is -3. 2 and 1 is 3. -12 and -9 is -21. Okay, we're off to a good start. I'm still going to work down column 1. Remember, I work all the way down, get what I want, and then I go over. So now I need to get rid of this +1. What I'm going to do is I'm in column 1, so I'm going to multiply row 1 by the opposite of that, negative 1. I'm going to add that to row 3 because that's what we're trying to get rid of. And I just wrote that down there when I should write it over here because that's where I'm going to write my new matrix. Okay. Oh, geez, eraser, duh. Okay, let's try it again. So we have our matrix. Now, are we actually messing with row 1? We are not. So 1, 1, negative 1, 6. And we are not messing with row 2 this time. So we're going to keep those values. I am going to mess with row 3. So I'm going to multiply row 1 by negative 1. So that gives me negative 1, positive 1, and negative 6. And then we're going to add those values down row 3. So the first one gives me 0. Second one gives me negative 3. Third one, 4. Fourth one, negative 5. Okay, not too shabby. So my first column is done. Done, first column. Now we're going to move over to the second column. My top, this number right here, I don't care what it is. Right here, I don't care. But I need this to be a 1. Usually, to get a 1, you're going to divide that row by that number that you're trying to change. So I'm going to write down row 2 divided by negative 3. Row 2 divided by negative 3. Now row 1, no change. Row 3, no change. What's changing is row 2. I'm going to divide everything, by negative 3. Negative 3, negative 3. Negative 3 0 divided by negative 3, 0. Negative 3 divided by negative 3 is positive 1. Positive 3 divided by negative 3 is negative 1. Negative 21 divided by negative 3 is positive 7. So we're getting there. We're getting there. I'm almost done with row 2. Now in row 2, I need this to be a 0. To get a 0, we have to consider I'm working in column 2. So I'm going to multiply row 2 by the opposite of this number. And then I'm going to add that to row 3. So we're going to multiply positive 3 by row 2 and add it to row 3 to get that 0 that I want. Now, am I messing with row 1? Nope. 1, 1, negative 1, 6. Am I messing with row 2? I'm really not. Row 2 is not changing. I am going to multiply, but row 2 is not changing. So now let's do the math that I said we're going to do. We're going to multiply row 2 by 3. So the red, 0 by 3 is 0, not 3. 1 times 3 is 3. Negative 1 times 3 is negative 3. And 7 times 3 is 21. And then we're going to add those blue values to 0, or to row 3. So 0 and 0 is 0. 3 and negative 3 is 0, which is exactly what I wanted, so I'm very happy. Oh, we have a little bonus. Look at our bonus here. I don't know if you'll recognize that. I'll explain in a minute. Negative 3 and 4 is 1. And 21 and negative 5 is 16. So we took care of row 2. We have our 1 and our 0 that we wanted. Good. And this is our bonus right here. Yay, little bonus here. Because we wanted a 1 there and we got it. So we don't have another step to do. Our matrix is now in row echelon form. Why is it in row echelon form? Well, because this variable is z, and we know it equals 16. So we got an answer. That's what row echelon form does for you. It gets you an answer for one of your variables. All right. What are we going to do now? Well, we're going to look at the second equation and say, okay, I keep writing x. Y minus z equals 7. We know Z is 16, so now we know Y is 23. Hooray! Last but not least, the top row says X plus Y minus Z is 6. X plus 23 minus 16 equals 6. X plus, is that right? I think it's right. X plus 7? Yeah? Is that right? 7? 7 equals 6. So X equals -1. Okay, so -1, 23, 16. Do you know what you can do with that? You could check it. Just saying. Since we use the first equation, let's check it in the third equation. I'm just going to do this verbally. So if I put, well, I'll do it visually up here. So if I take my answers, -1, 23, 16, and I put it in my third equation down here. So I'll have -1 minus 2 times 23 plus 3 times 16. Let's see what happens. I'll have -1 minus 46 plus 48 equals +1. -47 plus 48 equals 1. So I'm going to say, yay, we did the right answer. Check. And you can do the same thing instead of turning to the back of the book, especially when you're doing this on your test. Check your work. Okay, for 47, I've already changed that into the matrix. Since I have 3 variables, remember, I want it to look like 1, any numbers in the first row, 0, 1, any numbers in the second row, and then 0, 0, 1, any number in the third row. Well, we sort of look good because remember, we want to go down, work the first column, and then move over. I sort of have this, but not in the correct order that I want. In order for my math to be easier, I prefer to have a 1 in the top left corner to start. Now, we could certainly go through and divide row 1 by 2, but look at that. We'll have decimals, fractions, whatever you want. I don't want to do that. The easier thing in this case is to switch row 1 and row 2, and this is the notation for that. Put 2 arrows in between them, and that means switch row 2 and row 1. Okay, so row 2 is now going to be row 1. Row 1 is going to be row 2. Row 3, nothing. Okay, now we're looking a little bit better. We have that 1 in the top left corner. Our next job is to get this 2 to be a 0. Since I am in column 1, I'm going to multiply row 1 by the opposite of that number, and then I'm going to add it to the row in which it is sitting. Now, when I do that, row 1 does not change. So row 1 is 1, 2, -1, 5. Row 3, haven't even talked about it, so I'm going to write that one in there. Row 2 is what is written second, so that's what's going to change. Now, the first thing that we write is little fake math, so we're going to go multiply -2 times row 1. So -2, -4, +2, -10. And then I'm going to take those values and add them to row 2. So -2, +2, nothing, which is what we were going for. -4, -1 is -5. 2 and 3 is 5. And -10 and 0 is -10. Okay. We are done with our first column. Great. Now we're going to come over here and move to our second column. So we don't care about row 1 anymore, really. We have our 1 and we have our numbers. Row 2 is what we're concerned about. I need a +1 right here. Usually, to get a +1, we're going to divide that row by the number we want to change. So I'm going to take row 2 and I'm going to divide everything by -5. which means row 1 doesn't change, row 3 doesn't change, but row 2 is definitely going to change. All right, 0 divided by -5 is 0. -5 divided by -5 is +1, which is what we wanted. +5 divided by -5 is -1, and then -10 divided by -5 is +2. So we're getting there. We're getting there. In column 2, we're halfway done. Now what we want is we want this 2 to be a 0. Well, this 2 is in column 2, which means I have to multiply by row 2. So I'm going to multiply row 2 by the opposite of what number I have circled. So I'm going to multiply by -2, and then I'm going to add that to row 3, and that will take care of that 2 that we don't want to be there. So row 1 didn't touch it. Row 2 is mentioned first, so that's not going to change. What is going to change is row 3. That's what we wrote second. So how is that going to change? I'm going to go up here and multiply my blue row, row 2 by -2, and then add that to row 3. So 0 times -2 is -2, 1 times -2, -2, -1 times -2 is +2, -2 times +2 is -4. So we're going to add those down. We have nothing. We have nothing. We get 3, and then we get -3. So now we are done with column 2. We have our 1 and our 0 where we wanted it. Now we're going to move over to column 3, where we want this +3 to be a +1. Most of the time, to get a +1, we are going to divide that row. So we're going to take row 3 and divide it by the number we're trying to change to 1. So we're going to divide by 3. Now, row 1 didn't change. Row 2 is not changing. Row 3, however, we're going to divide everything by 3. 0 divided by 3 is 0. 0 divided by 3 is 0. 3 divided by 3 is 1. And -3 divided by 3 is -1. Now we have succeeded in finding our column 3 the way we want it to get a 1 here, because now this is in row echelon form. What does that mean? That means I have one variable, z, equal to -1, so I know exactly what that answer is. My second row says y minus z equals 2. Since I know z is -1, I have y plus 1 is 2, so y is 1. And then row 1, x plus 2y minus z equals 5. So x plus 2 times 1 minus -1 equals 5. So x plus 2 plus 1 is 5, so x equals 2. 2, 1, -1. Now we can check our work. I'm going to check this in the second original equation. Second equation. No, I'm not, because that's the same equation that I have. Yeah, I don't want to do that. That's the one I got my answers from. So I'm going to check it in the first equation. All right, so 2 times 2 minus 1 plus 3 times -1. So I have 4 minus 1 minus 3. So I have 0 equals 0. Check. We know it's right. So you can check your own work before you leave the test. Make sure you got it right instead of the back of the book. All right, moving on to 49. I've already made the augmented matrix. And since we have 3 letters, remember we want our top row to have 1 at the top and then numbers after it. Then we want to have 0, 1 with some numbers. Then we want to have 0, 0, 1 with some numbers. Okay. So I like to work in an orderly fashion in my first column. So I want to have a 1, a 0, and a 0. I do have the 1. I'm a happy person. The next thing I want is this 2 to be a 0. Since my 2 is in column 1, I'm going to multiply row 1 by the opposite, which is -2, and add that to row 2. Now, row 1 is not changing. 1, -1, 2, 5. Row 3 is not changing. What is changing is the second thing that is mentioned. Row 2 is changing, and that is after I multiply row 1 times -2. So 1 times -2 is -2. -1 times -2 is +2. 2 times -2 is -4, and 5 times -2 is -10. I'm going to add those numbers to row 2. So I will have 0. Then I have 3. Then I have -5. And then I have -10. Okay, so far so good in column 1. The last thing I want to do in column 1 is get this bottom left value to be 0. Now what's really nice here is it's already the opposite of row 1. So what I'm going to do, I'm not going to do any multiplying this time. I'm going to add row 1 and row 3. Now, row 1 doesn't change. 1, -1, 2, 5. Row 2 doesn't change. -5, -10. And row 3, I'm going to add row 1 and row 3. So nothing. -3, +3, 6. All right, column 1 is done. Now I'm going to move over here to column 2. So the first thing I would like to get is a 1. I also need a 0 in that column. Now, right now, I could certainly get a 0, and if you want to go that route, that would be perfectly fine with me. What I'm noticing, and this is just in my head, if you notice it, great. If you don't, that's fine. In order to get a 1 in that second row, usually you have to divide. You can add sometimes. I don't see anything that I could add in column 2 that would get me to a 1 in that space. And since I have to divide, if I look at the numbers in row 2 and I want to divide by 3, they're all going to become fractions. Most of you are allergic to fractions, but if you like fractions and you can work with them, then have at it. My recommendation, if I look at row 3, I can see that those will all be very nice numbers if I divide by the -3 to get the 1. So the first thing I'm going to do is I'm going to switch row 2 and row 3, and that notation looks like this. You have a double arrow in between each of them. So row 1's going to stay the same. I'm going to switch row 3 with row 2. And again, I'm only doing this for fractions, or for not fractions, I would say. Okay, so now what I can do, I can take row 2 and divide by -3 to get that 1 there, and I won't have any fractions. So 0 divided by -3 is 0, -3 divided by -3 is 1, 3 divided by -3 is -1, and 6 divided by -3 is -2. And then I have the 0, 3, -5, -10 from that switched row. So now in column 2, I do have the 1 without any fractions, and I want now to get a 0 where the 3 is. Now to do that, that's where you have to multiply and add kind of situation. So we're in column 2, so that means I'm going to multiply row 2 by the opposite and add it to row 3 where I want that 0. So row 1 doesn't change. Row 2 doesn't change. In row 3, I have to multiply row 2 by -3. Okay, so 0 times -3 is 0. 1 times -3 is -3. -1 times -3 is +3. And -2 times -3 is +6. Now I'm going to add those to row 3. So I'll have 0, I'll have 0, have -2, and I'll have -4. I'm almost done. I did get done with column 2, and so I'm going to move over, and the last thing I'm looking for is this +1 in column 3, which means I have to get this to be a +1. So to do that, I'm going to divide row 3 by -2. Okay, which means first row didn't change. 1, -1, 2, 5. 0, 1, -1, -2. And then when I divide row 3 by -2, dun, da, da, dun, da, da. 0 divided by -2 is 0. 0 divided by -2 is 0. -2 divided by -2, yay, is 1. And -4 divided by -2 is +2. That means we have row echelon form. Why do we have that? Because we now know a letter. We know that z is equal to 2. The second row says y minus z equals -2. So if I substitute that 2 in there, I get y is 0. And then the first equation, is x minus y plus 2z is 5. So I'll have x minus 0 plus 2 times 2 is 5. X plus 4 is 5. So x is 1, which means 1, 0, 2 is our solution. Okay. So what am I going to do? I'm going to check. I'm just going to use the second equation over there. 2 times 1 plus 0 minus 2 equals 0. 2 plus 0 minus 2 equals 0. That's totally true. So I checked my work, and I found out that I'm right. All right, 53, I've written the augmented matrix, and notice that it is not how we want it. We want a 1 just to make life easier on our math in that top left corner. And the rest of the columns we want to look like that. Okay, so the first thing I'm going to do is I'm going to switch row 1 and row 3. And actually I'm going to make negative row 3, and that way it'll be a +1. If you want to do that in 2 steps, you're more than welcome. So row 1 is going to become row 3. So 3, 2, 1, -7. And then negative row 3 is going to become row 1. So all those signs are going to change. I'll have +1, -1, -2, and 0. And then row 2, nothing's happening with them. So boring. Okay. So here we go. We want a 1 where the 2 is. 2 is in column 1, so we're going to take row 1, multiply that by the opposite, and add it to row 2. And that row 1 does not change. Row 3 does not change. So if I multiply row 1 by -2, I'll have -2, +2, +4, 0. I'm going to add those values to row 2. So I'll have 0, 3, 3, -3. Okay. So I'm getting there in column 1. Now I want my 3 to be a 0. It's in column 1. So I'm going to multiply row 1 by the opposite, -3, and then add that to row 3. Okay, so row 1 did not change. Row 2, all those pretty 3s. And row 3, let's see, I'm going to multiply by -3. So -3, +3, +6, 0. 1 times -3, yeah, okay. So I'm going to take those numbers and I'm going to add them to row 3. I will have 0. I'll have 5, and then 7, and then negative 7. Okay. Next up, well, column 1 is done, so we're going to move on over here to column 2. This 3, I want to be a 1, so I'm going to divide row 2 by that number. Row 1 does not change. 1, negative 1, negative 2, 0. Row 3 does not change. But row 2, I'm going to divide everything by 3. So 0, 1, 1, negative 1. Okay, not bad. I got my 1 where I wanted it. Next up, this 5, we need to be a 0. It's in column 2. So I'm going to multiply row 2 by the opposite number, which is negative 5, and add that to row 3. Okay. So since row 3 is mentioned second, row 1 does not change, row 2 does not change. I'm going to go multiply row 2 by 5. So I'll have 0, 5, 5, negative 5. I'm going to add those to row 3. So I end up with 0, 0, 12, I think 12, and negative 12. Okay, so column 2 is now taken care of. Last but not least, I need a 1 down there in column 3 at the bottom. So I need this 12 to be a 1. So I'm going to take row 3 and divide by 12. Okay, so row 1 doesn't change, negative 1, negative 2, 0. Row 2 doesn't change, but row 3, if I divide everything by 12, I have 0, 0, 1, negative 1, which is exactly what I want. I want all my 1s on the diagonals, and all these 0s over here underneath, because now it's in row echelon form, because now I know that z is negative 1. Okay, now I'm going to go, and row 2 says y plus z equals negative 1. So I can use that value that I already solved for. So I have y minus 1 equals negative 1, so y equals 0. Didn't we just have a y equals 0 a little while ago? Huh. All right, and then the first column, x minus y minus 2z equals 0. So x minus 0 minus 2 times negative 1 equals 0. X plus 2 equals 0, so x equals negative 2. So I think my final solution is negative 2, 0, negative 1. All right, I'm going to mentally, I have no room. I'll just squish it in down here. So 3 times negative 2 plus 2 times 0, I'm just putting it in the top equation, plus negative 1 equals negative 7. So negative 6 plus 0 minus 1 is negative 7. Check. Dun, da, 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 da. 65, the directions say, solve each system and write the solution in terms of z if necessary. So when they say that, they are expecting maybe you'll have infinite solutions. Now, we've discussed this before. Usually, if you have 2 equations and 3 variables, you're going to have infinite solutions. So if we were to just write this in a matrix, you can see the form doesn't even work. We don't have a third equation. If we wanted to write it, we could write it like that, which means, oh, look at that, 0 equals 0, infinite solutions. Now, we could go old school with just the variables, but, since we're playing with the matrices, let's do the steps. So I know all the zeros are down here, but let's get a 1 here. Just see what happens. I mean a 0 there, I'm sorry. So I'm going to take row 1 multiply it by -2, the opposite, and I'm going to add it to row 2. Now remember, row 1 doesn't change, so I'll have 1, -3. I don't know why I put the +2 there that moment. Still have my zeros written across here. So I'll have -2, +6, -4, -20. And then I'm going to add those to row 2. So I'll have nothing. I'll have 5. I'll have -5. And I will have -5. Well, very exciting stuff. Okay, so what does that mean? Well, I got my column. Now let's go get the 1 over there. And all this is doing is making our math a little bit cleaner. Honestly, not doing too much that we couldn't do with the letters. So what I'm going to do this time is I'm going to take row 2 and divide it by 5. So I have that 1 there. So 1, -1, -1. And then again, we have infinite solutions. So remember, the directions write in terms of z. What that means is when you have y equals, you want stuff over here with a z in it. When you have x equals, you want stuff over here with a z in it. So if we take our second equation, we'll have y minus z equals -1. So if I solve for y, I'll have y equals z minus 1. That is in terms of z. We're happy. So if I use this information, I can take the first equation, let me separate it out here, x minus 3y plus 2z equals 10. Well, I know that y is z minus 1. So I'll have x minus 3z plus 3 plus 2z equals 10. So I have x minus z plus 3 equals 10, which gives me x equals 7 plus z, or z plus 7. So what does that mean? So this is a parametric equation, and they wanted everything in terms of z. So z is its own value, y is z minus 1, and x is z plus 7, or 7 plus z. So every letter is in terms of z. What that means is if you pick any number for z, let's say 2, then you can figure out what is x, and you can figure out what is y. If somebody else picks -5, you can figure out that solution. There are infinite solutions depending on what value you pick for z. Okay, 69, wrote the augmented matrix. So we want our matrix when we're done with it to, I always put that, look like this, 0, 0, 1. All right, so to start this off, the good news is we have a 1 in the top left. We don't have to switch any rows. So I need the -2 to become a 1. I'm in column 1, so I'm going to multiply row 1 by the opposite, which is +2. Add that to row 2. So row 1 doesn't actually change. Row 3 definitely doesn't change. And row 2, if I go multiply the top by 2, I'll have 2, -4, 2, 10. So I'm going to add those to row 2. So I'll have 0. I'll have 0. Oh, I'll have 0. I'll have 12. Oh, we're done. We don't have to do anything because this tells me I have no variables equal to 12. That's what this tells me right here. So I'm done. There is no solution. If you want to, you could go keep working on this. But as soon as I see that and I don't have any coefficients for a variable, which means I have no variables, I'm done. No solution. It's over. Okay, last problem. 77. It says to obtain funds necessary for a planned expansion, a small company took out 3 loans. Okay, shockingly, I'm going to call those loans X, Y, and Z. So it says they took out a total. So here's my dollar amount. This is my dollars equation. Usually with dollars comes an interest equation. So each one of these amounts had an interest with it. So I'm going to say, now let's see. Now remember, I equals PRT. Principal, we don't know. That's our X, Y, and Z. This is our X, Y, and Z. The rate is our percent, and the T is time. Now, it says the company was able to borrow some money at 2%. It borrowed 1,000 more than half the amount of 2% at 3%. And the rest at 2.5%. Now notice, I just scanned over some of that information. My job for my interest equation is just to find out which ones had the interest. So we had a 2%, which is 0.02x. We have a 3%, so 0.03y. And we have a 2.5, so that's 0.025z. And then they're going to tell us about interest. They always do. The total annual interest was 305. Annual means once a year. So our time is 1. Now, if you want to go in and put a 1 next to all of your terms, feel free. I am vetoing that. It's times 1. So I don't need to multiply times 1. It's the same number. So I'm going to say the amount of interest is at 305. Now, just like on your quiz, there's always some wacky equation that's going to tell you your third, or some statement that's going to tell you about your third equation. And this one is the statement that says it borrowed 1,000 more than half amount of the 2% loan at 3%. Okay, so in English, what they're saying is the 3% loan. So which letter is the 3% loan? The 3% loan is Y. So they're saying the amount at 3% is $1,000 more than. So $1,000 plus, because more than, half the amount. So we're going to put half the amount at 2%. Which one is the amount at 2%? X. So that is our third equation. Okay. Now, how the heck are we going to solve this? We should be doing this by matrix transformation. That's how we can do this. You could go back and do it, with your 3x3 variable equations and keep your letters if you want to. But since it's in this section, I'm going to do the matrix. Now, the first thing along with this, just to make our numbers nicer, is I'm going to multiply this by 100. Why would I do that? Because it will change my decimals. Oh, I'm going to multiply it by 1,000. Darn it. It'll get my decimals out of the problem. 1, 2, 3. And I'm going to change this to 0.5. So that will say y equals 1,000 plus 0.5x. So I'm going to multiply this equation by 10 to get that 1 decimal out of here. So 10 and 10. So now this equation is 10y equals 10,000 plus 5x. All right, so what the heck am I doing all this for? X plus y plus z is 12,500. 20x, because I had to multiply it by 1,000, plus 30y plus 25z. That can't be right. Is that right? Yes, that's right. I apologize. 305, and we multiply it by 1,000. And then I'm going to bring this x this way. So it'll be negative 5x plus 10y equals 10,000. I didn't put my little commas up here. Okay. What the heck does that do for us? I'm going to move this up. Whoop. Make a matrix. So I have 1, 1, 1, 12,500. We're going to need a calculator, people. 20, 30, 25, 305,000. We've got negative 5, 10, 0, 10,000. Okay, now we're going to go get it in the form. See what happens. Let me make that a little bit clearer. That's a 30. All right, here we go. I need this to be a 0, so I'm going to multiply. This is column 1. I'm going to multiply row 1. Sugar. I'm going to multiply row 1 by negative 20 and add that to row 2. Negative 20, negative 20, negative 20. A lot. 12,500 times negative 20 is negative 250,000. Great. All right, here we go. Row 1 does not change. 1, 1, 1, 12,500. Row 2, well, row 3 doesn't change either. Negative 5, 10, 0, 100,000. Is that right? 100,000? That should be 10,000. Ooh, we don't want to start off with that bad thing. That'll never get fixed. That's not good. 10,000. 10,000. Okay. Sorry about that. Okay, so if we do this, we'll have nothing. We'll have 10. We'll have 5. And then we'll have a calculator. Negative 250 plus 305 is 55,000. 55,000. Okay. For our negative 5 to become a 1, I'm going to take row 1, multiply it by positive 5, and add it to row 3. What does that do? That says 1, 1, 1, 12,500. That says 0, 10, 5, 55,000. And then we're going to have 5, 5, 5, and then 12,500 times 5 is 62,500. 62,500. So, add those down. Nothing. 15, 5, 72,500. 72,500. Okay, not bad. All right, then, so column 1 is done. Next up, we want the 10 to be a 1. So I'm going to take row 2 and divide by 10. Row 1, 1, 1, 1, 12,500. Row 3, 0, 15, 5, 72,500. Row 2, 0, 1, I'm going to divide by 10. 5 divided by 10 is a half. If you want, you can put 0.5, or you can put a half. And then 55,000 becomes 5,500 when you divide by 10. So fun. Okay, now we want our 15 to become a 0. It's in column 2, so I'm going to take negative 15 times row 2 and add it to row 3. So row 1, 1, 1, 1, 12, 5. 0, 1, half, 5,500. Now I'm going to multiply row 2 by 15, negative 15. So I have 0, negative 15. Half of 15 is negative 7.5. And then 5,500, oh boy, 5,500 times negative 15 is 82,500. I'm going to add those amounts down. 0, 0. Negative 7.5 and 5 is negative, oh, this should be a negative 82.5. Sorry, you guys. Negative 2.5, 7.5 minus 5 is negative, whoa, that's wrong. I'm checking my work and I'm getting it wrong. 7.5 minus 5 should be negative 2.5. Negative 2.5, and then 82,500 minus 72,500, or negative 82,500 plus 72,500 is negative 10,000. Okay, last step. So the steps are still the same. The numbers are just a pain in the butt. So now I want to divide row 3 by negative 2.5. So row 1, 1, 1, 1, 12,500. 0, 1, half, 5,500. 0, 0, 1, and then 10,000 divided by 2.5, 2.5, 4,000. Okay, what the heck does that tell us? So let's call this our Z. So Z is 4,000. Based on my second equation, Y plus half of Z is 5,500. Half of 4,000 is 2,000. So Y is 3,500, and I am out of, okay, I'm out of room. I'm gonna move this up a little bit. Can I move it up? I can. All right, last bit. We've got X plus Y plus Z is 12,500, which means X plus 3,500 plus Z was what, 4,000? 4,000 equals 12,500. So X plus 7,500 equals 12,500. So X is 5,000. So we have X, we have Y, and we have Z. And I believe they're supposed to add up to $12,500. They do. That's my check. That's what I'm doing. So I'm done. You could check these. I am not going to do that because they do add up to 12,500. So I'm pretty confident. Whoa, what the heck?